Hello everyone, welcome to Applications Manager free training series on applications performance monitoring. Let's jump into today's agenda. So we are going to cover overall four parts, and in the first part, we will discuss and understand the application performance with the APDEX score. In the second part, we will explore how you can monitor code flows across applications via distributed tracing. In the third part, we will be looking at how you can directly pinpoint to the problematic elements in your application code. Lastly, we will visualize the dependencies in your application architecture with the help of automated service map feature. Now, here are some of the recent facts that we have gathered from the trusted sources like International Data Corporation and Foster. So, according to the International Data Corporation, 90% of the respondents are currently using observability tools, and this gives the administration a deeper insight to drill down the information of their application. Further, Forrester's research report states that 87% of engineers said that using a cloud native architecture has increased the complexity of discovering and troubleshooting incidents. So before discussing the topics in the agenda, let's start with why applications performance monitoring is required. Now just imagine a user who is accessing an e-commerce website and trying to purchase from an online store. Now after adding the required items to the cart, they are trying to attempt to place the order. So now, at the time of placing the order on the payment portal page, they encounter issues like the portal is taking long time to load or getting redirected to a different page, or it might be show some error codes or something, etc. A 404 error, it could be right. So operation could lead the loss of potential customers from accessing the application and leading it to a loss of business. And for the developers who are working on the web application will be unsure about the root cause of this problem. So in this scenario, the demand for using application has increased, which is also led the complexity of its development. So hence, it is necessary for the developers who are working on the application to make sure that the website is bug free and can handle the load in the application database to ensure providing a better service to their users. Now here are some of the contemporary trends in application monitoring. Let us see one by one. The first one is cloud native applications. Nowadays, simply large enterprises have adapted to move many of their applications to the cloud, where cloud native applications are scalable, flexible, and also efficient and use small independent building blocks like microservices, containerization, commonly Docker and Kubernetes. So developers and the operation team work closely together using DevOps practices. For faster and more reliable software delivery, such as monitoring this application, is essential nowadays. So, which also helps in analyzing how each part of the application is working and trying to fix any issues in handling a lot of users. The second one is artificial intelligence for IT operations in the context of application performance monitoring. So, AI and machine learning in recent times have been used to enhance and automate IT operations through anomaly detection for identifying unusual deviations. So, automate the by automating the IT task and predictive analysis for potential futures using the historical data and optimize the resource allocation for scaling based on the real-time performance is necessary. And the third one is user-centric monitoring. So user-centric monitoring shifts the focus from system-centric metrics to the actual end user's experience when they interacting with the application. So users' experience is also measured by examining their journey from the moment they access the application to the completion and identifying user-centric metrics such as page load times, the response time, and the overall responsiveness as the application by helping the developer to prioritize importance which enhance the user satisfaction within your application delivery. And the fourth one is application observability. So application observability, including application performance monitoring, will help in gaining insights into performance behavior and also the health of an application, which is achieved through monitoring applications, transactions. trace logs, execution time, and identifying the bottlenecks, errors, and inefficiencies in the code. The last is the full stack performance monitoring. The goal of full stack performance monitoring is to identify and address the performance issues across the entire application stack from the front end user interface to the back end infrastructure by monitoring various layers of the stack. So, which including the application code, server response times, the database queries, and this is achieved by collecting the real time data on various performance metrics like the response time and the error rate. So, by adopting these latest trends, which we have discussed right now, organizations can gain more insight into the performance of their application. In real time, it is helps us to enable the users to have a proactively and the developers to have proactively identify and also resolve any potential issues before they impact the end users. So, this will ensure that maintaining reliability, availability, and responsiveness of modern applications is necessary. Let's explore the benefits of modern versus traditional approaches in building an application. In traditional approaches, the application were hosted on on-premise or a single data center server, which may experience high downtime and limited availability. That is leading to a potential performance issues during the traffic periods. However, leveraging cloud computing and containerization for better availability and utilizing features like load balancing, redundancy, automatic failure, and global distribution has minimized this downtime, enabling continuous deployment without affecting the user experience. The scaling of traditional applications involves purchasing additional hardware and substantial investment in infrastructure. Also, high maintenance costs due to the need for physical hardware updates and repairs. So, with the help of cloud based monitoring solutions, reducing the upfront cost, allowing efficient utilization, horizontal scaling of resources based on the demand, automation, and containerization contributed to the operational cost savings. And the third one is the global content delivery. So, content delivery may be constrained into a specific location or a data center where the users in a different region might experience latency and slower performance. Now, using content delivery networks and edge computing will ensure a faster and reliable delivery globally. Further, cloud services offers distributed content across multiple servers globally, so reducing the latency of the users worldwide. So this improves the user experience and ensures consistent performance worldwide. The last is the operational efficiency. So, managing and maintaining the traditional applications will involve manual processes for their deployment, scaling, and maintenance with limited flexibility and agility responding to the changing business requirements as well. So, nowadays, DevOps practices such as infrastructure as code, continuous integration, continuous deployment pipelines, and container orchestration tools will help automate the process by enhancing operational efficiency, and the microservices architecture enhances agility and scalability for evolving applications. Further, updates can be rolled out seamlessly without any downtime, and resources can be managed programmatically. So, in this summary, in a nutshell, adopting a modern approach to building applications will offer advantages such as improved availability, cost reduction, global content delivery, and operational efficiency. So, when compared to the traditional methods, cloud computing, automation, and modern architectural principles are key factors that will contribute to these benefits. So, enables businesses to stay competitive and responsive to the changing demands. The modern approach will offer benefits such as improved scalability, again reliability, and global content delivery, which will contribute to the higher availability when compared to the traditional approaches as well. So far, we have discussed why application performance monitoring is necessary in the Applications Manager, and the performance monitoring feature in Applications Manager is called APM Insight. So, APM Insight will give you an understanding of the way how your application behaves for your end users who are accessing it within an end-to-end transaction method across the world across the world in your entire application web stack. So if any performance issues were identified, we can sort that as well. So you can analyze the root cause of the problems much faster by performing the first level of troubleshooting. The supported technologies in APM Insight are Java, Node.js, .NET Core, .NET, Ruby Rails, Python, and PHP as well. Now, here, these are some of the factors that will play a crucial role in determining the performance of an application. Let's see each one of these factors. The first one is response time. When a transaction is made by a user in the web application, the request is sent from the application layer, which will travel through the transaction and the network layers and hit the application server, and this request is served back to the end user. The response time is taken from the transaction that to be processed, which includes the time taken from the initiating request to receiving the final response. The query response time is taken by the database query to retrieve and return the data or spend at which database queries are executed. Slow queries can significantly impact the overall application performance. So the application performance response time is the time taken by the application to respond to the user inputs or requests, which will include the processing time, the network latency, and any other delays. Further, the application code, we know that bugs in that application code can lead to unexpected behavior or failure, right? So thrashes or performance degradation, inefficient or excessive exception handling can impact the overall performance, and the frequent exception might indicate issues that need frequent attention. So, when an error occurs, a stack trace provides information about the sequence of the function calls leading up to the errors. So, analyzing these stack trace will help in identifying the sources of the performance issues. The third one is memory. Monitoring the application's memory consumption is crucial nowadays. Higher memory usage can lead to performance issues and even crashes could happen. So, if the application exhausts its allocated memory, it might crash or become unresponsive. This occurs when the program doesn't release memory properly and leading to a gradual increase in the memory usage over time. The last one is the database. Database queries that will take long time to get executed can impact the entire application's responsiveness. Optimizing these queries is a very essential, and the number of calls made to the database can impact the performance as well. So, reducing any unnecessary or duplicative database calls can improve the overall speed of the application. Hence, monitoring and optimizing these factors are essential for maintaining good application performance. Various monitoring solutions can help to identify and also address performance issues in these of the areas. Also, regular performance testing and tuning are very essential for ensuring the application to run smoothly. Now, the application performance monitoring insight is a tool that uses agent for monitoring the application. The initial setup will involve deploying the agent onto the servers where the applications are running. So once it is done, these agents are responsible for gathering the performance data and transmitting it to the applications manager for analysis. The agent within the application server utilizes the method bytecode instrumentation to track the individual user's transaction as they navigate through the application stack. Then it will send this transaction data to applications manager as a at a fixed time interval. And this approach will enable detailed monitoring of the transaction performance, facilitating an identification of the bottlenecks or any performance issues occurs. The tool will offer code level visibility, allowing monitoring of slow database queries and their performance by capturing the real time user interaction with the application. So, users can configure any alerts and notification based on the predefined threshold for metrics that impact their application performance. Further, when the application performance reaches this threshold, the tool will send an alert to the IT team. So this alert system will help the developers and the IT team pinpoint the areas that require improvement in the performance, such as application code, database related issues, and page load times. So this proactive approach helps address the issues promptly and minimize the downtime. Now let's see exporting and elevating the performance using the APM inside data exporter. The data exporter is a standalone component or a module within the applications manager for collecting, processing, and sending application metrics and traces for communication with the applications manager server. So its purpose is to export the data related to the application performance monitoring inside. So the data exporter operates as a separate independent process, which means it will run automatically from the other components or services within the applications manager. The primary function of the data exporter is to handle and transmit the information related to the application metrics and the traces to the applications manager. So the metrics will include various performance indicators such as response time, the error rate, or the resource usage, and the traces, and typically which will refer to the detailed records of the execution flow of a transaction or the request within the application. A single instance of applications manager data exporter is capable of managing data processing for multiple applications. This implies that the exporter is designed to handle the data exporter requirements for various applications simultaneously. The exported data is then sent to the applications manager server. The server will analyze this data and provide insights into the performance and the behavior of the monitored applications. Now, this is the overview of the data flow through a data exporter. So the data exporter supports agents written in Python and PHP. These agents are responsible for monitoring the applications to capture their metrics and traces. Developers or the IT team integrate the supported agents into their Python or PHP applications. So now these agents will collect the performance metric, the traces, the other relevant data from the application. A single data exporter instance is set up, which will handle data processing for multiple applications. So once it has been set up, it acts as an intermediate layer between the application and the applications manager server. So the application will continuously generate the data related to its performance, like traces and the other metrics. This data is collected by respective agents, and this that is Python and PHP, which are running within the applications. The data exporter will process the collected data to aggregate, filter, and format it properly for transmission. So this step will involve organizing the data in a way that is compatible with applications manager's requirement. So once the data is processed, the data exporter will establish communication with the applications manager server. We will then send the aggregated and formatted data to the server for further analysis and storage. So this approach, the applications manager server will receive the transmitted data from the data exporter, stores the data in a centralized repository, and will provide the user's interface for monitoring and analyzing the application performance, traces, and metrics as well. So the system administrators, the developers, or the IT team can make use of these traces or the application to identify and monitor the health performance, which will help in identifying the bottlenecks or the performance issues and optimize the application behavior. Unfolding the advantages of data exporter. The first one is APDEX score will be more helpful in improving the customer satisfaction. The second and the third one is using the enterprise tool. By using this enterprise tool, you can pre-analyze the data and enhance the security to reduce the network load from the application. Further, you can alert your development team in prior and make changes when the application goes down, which can improve your application in efficiently commuting and provide customized data transmissions within your infrastructure. Here, these are the some of the key performance indicators in APM Insight. The first one is the AppDex score. APDEX score is a numerical measure of user satisfaction with the performance of application's response and how the application occurs to the how the application responds to the end users. So the second one is the response time. It measures the average time it takes for the application to respond to the end user request for the transaction across the application. Lowering the response time is generally more desirable. The third one is the request, which is the total number of requests made to the application within the specific time frame and help to decide the overall workload and the usage of the application. The fourth one is the data throughput. It indicates the amount of data in bytes transferred or processed in and out of the network request by the application during the monitoring period. So, which will also help in understanding the application's data handling capability. The fifth, exception. It will track the number of exceptions, errors, or failures that occurs during the cycle of transaction in a chosen duration processing of the request. So these exceptions could be various types of errors such as server errors, timeouts, or other issues that affect the application's normal operation. Let us understand the application performance with AppDex scores now. The AppDex score is categorized based on the application's responsiveness. The first one is the user satisfaction. So this category represents the highest level of user experience where the application's response time is between the satisfied threshold and the excellent threshold. The users in this category are generally satisfied with the application's performance. The second one is tolerance. The tolerance category indicates that the application's response time is between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance but may not be entirely satisfied under this satisfied category and this tolerating category. So the last one is frustration. So this category represents the lowest level of user experience where the application's response time is below the tolerating threshold. Users in this category are more likely to be frustrated within the application's performance as it does not meet the expectation. So, checking the application performance with the AppDex score, very important. So, this application performance index or the AppDex score is a standardized metric that is used to measure user satisfaction and application response time. The AppDex score scales ranges from 0 to 1, where 1 being the best score and representing excellent user satisfaction. So, based on the total samples that are collected, the AppDex score is calculated as a sum of the satisfied plus half of the tolerating count over the total samples that are collected during the transaction. So by having this aptX score, we can able to identify in a glance whether our users are satisfied, tolerating, or whether they are very frustrated within the application. So some of the advantages of monitoring the application performance with aptX score. So let's see one by one. The first one is user-centric performance measurement. Uh, the first one is user-centric performance measurement in order to understand the application behavior. So, which will help you to understand how each application's performance directly impacts the user experience and enable you to prioritize the improvement. The second is easy understanding of complex performance data with a common performance metric, which will simplify the complexity of the data into a single and easily understandable metric by providing a clear and standardized way to assess the application performance. The third one is you can benchmark and compare the performance level of different applications, which allowing you to identify the high performance application leading to consistent improvement across your IT environment. The fourth one is proactive issue identification and the prioritization of the code optimization. So when the performance falls below the acceptable level, the AppDex score will help you to identify the critical transactions with low scores. Highlight also it highlights the areas for core optimization as well. And alerts are triggered by enabling quick issue identification and improving the key transaction that impact user satisfaction. At last, The historical APDEX trend data will allow you to analyze the performance pattern over time and it will help you to understand the performance trends and identifying the improvements for ensuring a consistent positive user experience all time. By now, you would be more interested in configuring the key business transaction to monitor the entire performance of your application effectively. In this slide, we shall see on the configuring the key transaction of your business operations, which could be a high volume of activities made in the application. All the transaction would be captured, among which you can select the key transaction that you want to monitor and try to set a threshold based on the response time of this transaction. Now, how to monitor the code flows across applications via distributed tracing. So in this microservices architecture as shown in the image, it is necessary to monitor the transaction made between the two or more applications or services. So with the distributed tracing feature, we should able to monitor these microservices, and using this, you can also track the transaction made between the two or more applications that are collecting data in between these microservices. Now just understand how the tracking is done in the distributed tracing. An API request is made by an application to another application. The APM insert will add an HTTP header containing the metadata that is required to track the request. If the APM insert is enabled in the other application, it will process the HTTP header and return the tracking information to its caller via response headers. The other application is turn calls another service. The header propagation will continue and it trace all the parts that are taken by the original application across the distributed system. So using this data, we can monitor and start time, that is when the transaction was initiated, the response time taken for the transaction to respond within the application, and the name of the transaction and the application. So these things can be tracked. So by clicking on the expand view as seen in the screenshot of the application name in this slide, you can view the method calls and the code blocks as well, that has which has taken a significant amount of time to complete the request, and this will enable you to monitor the calls made between two applications and narrow down the problems effectively. So here we have the auto scaling feature in APM Insight. So auto scaling is an automated way of managing the resources of your application. Just imagine you have a website or application running on your cloud environment. So whenever the application automatically scales up due to a higher user interaction on the site, and to handle the extra traffic, a new instance will be added. However, when these applications are scaled down due to fewer user transactions or interactions, this newly added instance will become unused and is still retained, right? So this will lead to the license being consumed by the unused instances. So which will be resulting the new instances not being added for monitoring. So hence, with the help of auto scale mode in the APM Insight, you can overcome this scenario by automatically unmanaging or deleting the unused instances in the cloud environment. You can just enable auto scaling option in order to avail this feature. Now we can go move on to the pinpoint the problems of the elements in the application code level. So let us see the need for eliminating the issues in problematic code. You are aware, stack trace represents the movement of an application during the execution of a program. So when the Java application throws an exception, the stack trace gets logged within it. So by enabling the stack trace provided by the APM Insight, the developers can pinpoint the exact line of code and have the sequence of functions that is leading to the problem that was reported. So this information will help them to understand the root cause of the problem and can make the code optimization or bug fixes to eliminate the issues and improve the application performance as well. So with the help of the stack trace, the developers can efficiently troubleshoot and also resolve problems within the application's code, ensuring a smoother and more reliable user experience. So here, now by gaining a deeper visibility into Java-based application performance using context-based monitoring, you can enable context-based monitoring for your Java applications as well. So this will allow the tool to track and trace individual users' transactions, capturing their data and how each registration transactions flows through the application server. Let's say your application server has three Java applications running on it. By default, transactions of all these applications coming from the same application server are shown collectively under the Web Transactions tab on the APM inside. So in this image, as you can see, the Tomcat application is the application monitor name, and the JPEG store sample and the sample web page are the three contexts running on the same application server. So the transaction of these three Java apps are listed in the Web Transaction tab. Now, with the context-based monitoring, you can monitor the performance of all the individual applications running in the same application server separately. So, which will help you to analyze your application performance. This means that by enabling context-based monitoring, the transactions of the JPEG store, the sample web page, and the store sample can be viewed separately as well. Further, we have introduced the RUM analytics feature in APM Insight. So, in APM Insight, the RUM analytics feature will provide real-time insights into user interactions, allowing businesses to monitor and optimize application performance effectively. So on the front end level, by tracking the key metrics such as response time, page views, JavaScript errors, and geographic performance trends, it helps identify slow transactions, errors, and the performance bottlenecks across different devices and locations. So this data enables organization to proactively optimize their application behavior, so ensuring a seamless user experience and improved overall performance. Also, we have the application dashboard in Applications Manager that provides a comprehensive view of the application performance and the user experience by combining the data from APM Insight and real user monitoring. So this integration allows for a unified summary of both backend and the user level X performance. So that helps IT teams to monitor key metrics such as APDEX scores, user sessions, failed requests, slow transactions, and error reports. Additionally, the dashboard provides geographical insights to help analyze performance trends across the different regions as well. So, by using this dashboard, organizations can quickly diagnose issues and optimize their applications to ensure a seamless user experience. So next, we have also revamped the Ad Monitor page of our APM Insight to simplify the onboarding process. So which will make it more flexible and user friendly for for the users. So now with this structured step-by-step flow, you can effortlessly configure the APM Insight monitoring setup in Applications Manager. Added to these mentioned features, we have introduced the instance level alarm metrics feature that allows users to configure alarms one using a more granular set of performance indicators at the very instance level. So this enhancement provides precise monitoring by enabling users to select a specific monitor and associate thresholds with these key attributes. By setting alarms for these instance level metrics, businesses can proactively track performance deviations, identify potential issues, and optimize application behavior more effectively. Going to the last slide, visualize the dependencies in your application architecture with an automated service map. Now, what is service map? So service map is nothing. So it will provide you with a complete overview of the application infrastructure along with the connections to the other dependent resources. So the main purpose of a service map is to identify the status of the application that is related to instances, monitor the key metrics like response time, throughput, and status of the connection, and detect and troubleshoot any application problems before the customers are impacted. And also, it will help us to identify the number of failed request counts. So there are three types of service map available. So one is the map view, and the other one is a table view, and the final one is the graph view. This is the map view, as you can see in the slide. So it will provide a way of analyzing the topological view of the application along with the instances represented in the central node. So now let me take you to the applications manager UI and showcase all these how all these can be achieved in the APM Insight Monitor, and discuss generating some reports and configuring alarms for the performance metric. Also, we will discuss on the newly mentioned features. Okay, I hope everyone can see my screen now. So this is how the applications manager user interface looks like. So if we go on to the new monitor, add new monitor. So under this page, we can have the complete set of infrastructure monitors along with the real user monitor and the APM Insight monitors that is supported. We have categorized each infrastructure modules, so like the cloud apps and application apps. So under the APM Insight, we can able to identify over here. So these are all the supported technologies as I mentioned as we discussed in the slide. So now also we have the separate tab for application performance monitoring, which is the APM tab. So under the APM tab, we can able to see what are all the monitors that were already onboarded. So now I want to add a new monitor. So in order to do that, we need to click on the add monitor. So here we need to choose on the framework that we are going to for which our application is hosted. So I'm just choosing the Java application right now, and this is the newly revamped add monitor page that I talking about. So we do have the manual steps as well, so which is a quite are difficult. So compared to the new ad monitor page, so which we have brought this for a seamless adding monitor experience. So we need to choose the deployment. So I'm just you can either deploy your agent in the container or the server. So I'm just choosing the host. So which is I'm choosing the Windows or Linux, right? So I'm just choosing the Windows. So I'm going to choose a Tomcat, Apache Tomcat. So here once done, I'm going next. So here in this configuration tab, so I'm going to give my application name and the default port that is running and what is a specific of my Java application version. And once that under that one setting, I can able to see we need to provide the applications manager details. So automatically it will be fetched, and here we can have the license key as well. So once that these details has been entered, we can go to the command execution. So this can be done automatically. So once we have configured all the arguments, the monitor will be added. So we are currently accessing in a demo page, demo.app manager. It is still accessible for all everyone. So if you want to just have a quick glance, you can go to this add monitor page. So once this add monitor page, we have onboarded the specific Java application. So it will be available under the applications tab. So here as an overview, we can check the availability of the each application. So here in this page, we can see Java application, Ruby application, and Node application, etc. So I'm just want to get into the Java application. So after clicking into the Java application, so under the overview page, I can able to see the top metrics that were discussed: the APDEX score, the response time, request, data throughput, and exceptions as well. So currently, this data has been fetched for the last 30 minutes. If I want to sort out for any time, we can sort out that specific time frame. So I'm just choosing the last 6 hours over here. So under the last 6 hours, I can able to see users, those who are access my applications are 98% is satisfied, quite 1% is tolerating, and 0.8% is frustrated. And what are all the average response time that was taken in this specific time frame, and how many requests that were made, and what are all the data throughput and the exceptions that were made in between this time frame. If I scroll down a little bit, I can able to find the response time that is broken by components. Here we have this beautiful graph. So if I can see in this specific time frame, there is a spike. So by hovering to this, I can see the overall response time was taken higher compared to the HTTP call and the application code. So these are all the some transaction level bars that we can see. So now, as an application owner or application developer, so how this APM insight flow works. Let's say, uh, as an application owner, we may have our application under thousands of transaction or a hundred of transactions. Now we are unable to not sure which transaction for the users is taking more time to load, right? So in order to sort out that specific thing, we have this top five transactions by response time. So by having this for top five transaction, we can able to identify what are all the top transactions that is taken more time for the end users to access it. As I can see this specific transaction, now I want to drill down into the bottleneck that is causing this specific transaction more response time. I'm just clicking on this specific transaction. So it will take us to the transactions tab. So here in the transaction tab, we have the table view and the graph view as well. So under the graph view, we have the APDEX score for that specific transaction that was made. So currently, it is taking around average response time is taking for this transaction is to continue is around 1.39 seconds, and total these are all the requests made. So here we can see the transaction traces that led to this specific slowness of the transaction. So we will come to this, and before that we can see the response time that is broken by the components. By hovering to this, we can see at what are the time frames, what are all the application code that is taking more time, and what is the pg sql calls that if it is more taking more time, and if the overall response time if it is taking more time, we can able to identify over here. And it will also have the table view, and what are the request throughputs, the data throughputs, those things can be identified over here. So now I can see these two traces that is taken 238 milliseconds on this specific time frame. If I want to drill down into the specific date trace, I'm getting into the specific trace. Here I can see the method calls level details. So currently for that specific trace details, I can see the response time is around 238 milliseconds, and the CPU time that was taken is around 78 milliseconds. Totally 1949 DB queries and 149 external calls has been associated with this specific transaction. So which might be a root cause for this transaction to have slow method calls. So here I have the method calls. So by clicking on the drop down, I can see this is one of the database call that was occurred, and this is one of the method call that was occurred that led to the higher transaction level. So now, as a DevOps engineer, so what my duty is to, I will take a complete screenshot using this feature. So I will take a complete screenshot and share it with my development team, so they can able to optimize the specific database query or the method calls that is causing this specific transaction have higher response time. Further, along with the trace details, what are all the SQL statements that were associated with this transaction. So by sorting out with the query, I can see this is the top query compared to the others taking more response time. So likewise, if there are any external calls that were associated, I can see there is a Postgres database external call that is associated with that specific transaction. So by sorting out the execution time, if it is a production environment, definitely there will be some more execution time that is taken by the database queries, right? So we can share this information with our internal team or the development team in order to optimize it. So along with that, if there are any exceptions that is available for the specific transaction, we can find those exceptions in this exception tab. So here I can see currently error syntax is available message, the PSQL exception. By clicking on the exception class, I can see the complete stack trace. So we can share this stack trace within our development team to optimize and fix the specific issue. So which will help us to optimize the application. Also, this response time can be reduced. That can be leads to a successful user experience. So if there are any other transaction, so that is also okay, I can be able to identify here. So from the overview page, we came up to the transaction flow, transaction to the traces. So this is how the flow works. In case if you want to drill down into a specific transaction. So we can go into the specific transactions as well. So under here, we can sort out the transaction level. As I can see, if I sort out using the average response time, so this is the transaction that we discussed even before, and this is the same transaction that is having the higher response time compared to the other transactions. So we can make the key transactions. So we can have this transaction to be marked as a key. So in case if we don't want all the transactions to be tracked and we want to only track a few transactions, and if we continuously optimizing it, we can have mark as a key transaction, and that specific transaction can be tracked over here. So this is under the transactions tab. So here we have the database tab. So this application, if it is associated with the database pgsql, so here we have all the queries that is getting executed within the application level. So the select query, update query, insert query, or delete query. So by clicking on all, I can see all the queries that is being executed in the backend of the application. So here, if I want to identify database operation that is having more time, I can just sort out by the average response time. So compared to the other database operations, this specific query is having a more response time. So by clicking on it, I can drill down to that average response time and how many requests that was made and what is the recent transaction traces if it is available. So these are under the database level. So now, as we have already seen the traces tab, we are going to move to the JVM. As this is a Java application, we can see what is the Java memory that is taking for the application. So what is the CPU that is getting used by this Java application? What is the JIT time, the runtime memory, and how many classes are loaded and unloaded? So if we scroll down a little bit, we can have the complete comprehensive view of the Java. So by having this comprehensive view within the Java classes count and the runtime compiler, we can have a classified view that if anything that is getting into a bottleneck, we can have the data to work with our internal teams. Also, we have a separate tab for exception. So under the exception, so application might receive some 401 error or a 403 error, 400 error. So these errors can be tracked. If there are any top exceptions, we can able to track down the exceptions and the code level stack as well. So here we have the service map. Along with the exceptions, we have the service map, which we have discussed in the slide. So this service map, as I mentioned, currently we can see this application instance is associated with the PGSQL database and what is the health of status. So by hovering to this, we can see the average response time, how many requests are getting failed when the application is connecting to this specific PGSQL instance. So we can have the map view, and also we have the table view, and it is also able, we can able to see under the graph view also, beautiful graph view also. So under the app parameters, by default we can monitor the JMX parameters. If you want to add any specific parameters, we can add it that as well. So under the thread profiling, obviously we can able to create some threads in demand. So it is the thread that was created previously. Under here, I can see the current threads what are the threads that is taking more time and what is the stack trace that is causing the thread to be blocking or taking more time for the application to deliver a seamless performance. This specific thread is having a 24.56 seconds of CPU time and 4 GB of memory that is been allocated, and this is a stack trace. So we can able to share this stack trace with the developer concern team in order to fix this as soon as possible. So once this is done, so we can have the rum analytics as well. So the rum analytics, it can be inferred under here. Okay, before that, let me move into the application dashboard. So as I mentioned, we have this specific application dashboard. So under here, so under this application dashboard, we can have the comprehensive view of the real user monitoring, which is going to be a front end level, and the APM insight monitoring as well. So we can have the complete success rate and the worldwide summary report over here. So if I want to configure some alerts, so we can get into the applications manager tab, performance monitoring tab. Here, so let me show you how to configure some alarms. So I'm just choosing this specific instance. So as I mentioned, we have introduced a feature to configure alarms in the instance level. I'm just getting into the host. Okay, it is a demo page. So I'm just getting into the application inside. So under the monitor actions, we have the configure alarms tab. So here under the configure alarms tab, so these are all the primary metrics for which we can configure alarms to have a seamless performance, to avoid any bottlenecks, or to get notified within our internal team. Sure. And then here, this is the RAM analytics that I'm talking about. So in this RAM analytics, we can have a comprehensive view within the real user monitoring, which is the front end. And here we do have the APDEX score within the front end level. Likewise, the application performance monitoring. For that, we do have the response time and how many pages that have been viewed in the front end level with the help user experience. So under the user experience level worldwide chart, we can have this beautiful geographical view. By clicking on the specific country, we can see what is the APDEX score in each of the countries and how many page count. So those details can be able to view under the RAM analytics, which is introduced in the recent enhancement. So if I want to choose any metrics, I can just go to any one of the transaction tab. If I want to pull out as Excel report, I can pull this as an Excel report as well. So this is an overview of the applications manager user interface. So now let's have a quick recap of today's session. So in the first part, we have discussed how to track application performance monitoring performance using the APDEX score. Next, we explored how to identify the problem in the application code. In the third segment, we saw how to track transactions from one application to another and debug the issues. In the last part, we encircled identifying problems in the code stack and concluded by discussing on how service map makes it easier to identify the problems. Thank you everyone